Imagine an icy object hurtling through space larger than the island of Hawaii. That's how big the Bernardinelli-Bernstein comet might be. Announced in June 2021, the comet is huge and it's approaching the inner solar system. What might we learn from this comet? And more importantly, does it pose a threat to life on Earth? This is Unveiled, and today we're answering the extraordinary question, what do you need to know about the recently discovered megacomet? Do you need the big questions answered? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more thought-provoking content. Bernardinelli-Bernstein was discovered by two astronomers, Pedro Bernardinelli and Gary Bernstein, based on archival images dating back to 2014. Their announcement quickly took off in the media. The comet is, according to some, the largest comet yet discovered in the solar system. And though not every astronomer agrees with this designation, what isn't in dispute is that it's absolutely huge. It's estimated to be around 100 miles across and is currently heading toward the Sun from its home in the Oort cloud. When discovered, it was as far away roughly as Neptune. The distant comet has even been imaged, and those images are public. News of any astronomical object of this size in the solar system is sure to get people talking, with many worrying that the comet is on a collision course with Earth. Luckily, that's not the case. The comet isn't actually going to get that close to Earth as it completes its orbit around the Sun and will be sitting pretty at a distance of around 10 to 11 astronomical units. That's around 1 billion miles away from us, so we really have nothing to worry about. In fact, the comet's closest point to the Sun, its perihelion, is about as far away as Saturn. Suffice it to say, there's no risk of Saturn crashing into the Earth, and there's no danger of this comet doing so either. But just because this comet isn't a world-destroying, potentially hazardous object doesn't mean it's not extremely interesting and important to study. However, Bernardinelli and Bernstein weren't looking for a comet at all when they made this discovery, let alone the largest and most distant comet yet discovered in our whole star system. They were actually looking for something a little different: trans-Neptunian objects. Trans-Neptunian objects, or TNOs, are any objects beyond Neptune, as the name suggests. The first and most famous TNO ever discovered was Pluto, which was even believed to be a planet in its own right for decades, until the discovery of the second TNO, 15760 Albion, in 1992. Yes, it took 60 years to find another, because most astronomers simply weren't looking for them. Today, there are many more, including objects like Eris, Haumea, and Pluto's moons, and it was additional TNOs that Bernardinelli and Bernstein wanted to find. To do this, they used the results of the Dark Energy Survey, a long-running experiment being conducted by the Cerro Tololo Inter-American Observatory in Chile, South America. As you'd expect, the Dark Energy Survey is preoccupied with unraveling the mystery of dark energy rather than studying TNOs. It does this by taking images of distant phenomena beyond the visible light spectrum, namely supernovae and galaxies. This is a far cry from discovering monster comets, so how did the discovery come about? Well, Bernardinelli and Bernstein wanted to study the Dark Energy Survey's data in the hopes of finding smaller, nearer objects between Earth and galaxies millions of light years away. As Bernardinelli himself said, quote, "When you take an image of the sky, you're not taking just an image of the galaxies, you're taking an image of everything that is between you and them." He added, "You get things like stars, you get airplanes, you get asteroids, and everything else in between," end quote. Confounding as the mystery of dark energy is, they weren't looking to use the data to unravel it, instead coming up with a way for a supercomputer to sift through the DES's data and find TNOs. But they found this monster comet instead, which in 2018 finally grew a tail, allowing it to be officially designated as a comet and not an asteroid. They used supercomputer time and identified 800 detections of distant objects, most of which were TNOs. But 32 belonged only to this enormous comet, which was clearly something special. The duo has admitted that they were the last people who expected they'd find a comet, given that they weren't looking for one at all. But the comet will now bear their names forever. So what will we be able to learn from the comet? For a start, it teaches us that comets can be absolutely enormous, with this one being roughly 10 times bigger than the solar system's average comet. When it's much closer, we'll also be able to look at it with various powerful instruments and find out more about its composition, its age, and so on. This will give us invaluable insight into the solar system's most mysterious region, the Oort cloud, which in general is where most long-period comets come from. The Oort cloud is a huge shell of icy bodies that is many thousands of astronomical units away from the Sun, with the inner edge no closer than 2,000 astronomical units away and the outer extending all the way to somewhere between 100,000 and 200,000 astronomical units. It's so mysterious, we're not even sure how far out it reaches. Because many long-period comets come from the Oort cloud, their orbital periods are unfathomably large. Bernardinelli-Bernstein, for instance, will take millions of years to complete its orbit. In fact, it was furthest from the Sun 1.5 million years ago. That means that the fact that we're here on Earth right now and will be able to see it as it comes close is incredible. We're very lucky to be living on Earth at this time, especially if it really is the solar system's largest comet. How many humans in the future will be able to say that they remember when the biggest comet in the solar system came within 10 AU of planet Earth? It's going to reach this point in April of 2031, but unfortunately you'll need a telescope to see it because of its size and distance. Though it's enormous for a comet, for a dwarf planet it's actually quite small. Ceres, for example, is both far larger and closer than this comet, with a diameter of about 580 miles and an average distance of 2.77 astronomical units. And in general, we can't see Ceres with the naked eye. You're going to need binoculars or a small telescope to spot it. And you have to know enough about the night sky to actually identify it. Luckily, you have plenty of time to get yourself a telescope and learn how to use it if you really want to witness this once-in-a-lifetime flyby yourself without relying on space agencies to publish photos. But what if the worst does happen and a comet does start to head towards Earth on a direct path? Well, a comet of this size would be horrifying. NASA has designated around 1,500 near-Earth objects, which are potentially hazardous asteroids and comets. To qualify for this designation, these objects have to be extremely close, only 0.05 AU away from us, and of a specific size, at least 100 meters or 330 feet across. Considering Bernardinelli-Bernstein could be around 528,000 feet, it's horrifying to think that something so comparably small is dangerous enough to be designated such by NASA. In fact, the largest NEO of all, 1036 Ganymede, is 22 miles across, making it a quarter of the size of the monster comet heading for the Sun. There are no two ways about it. If a comet of this size collided with Earth, it would almost certainly wipe out life on the planet with its impact and with the devastating weather conditions that would follow. It would be much like the asteroid that wiped out the dinosaurs, only far worse, because that asteroid was likely only 6.2 miles wide. Once again, though, there's absolutely no danger of this particular 100-mile-long megacomet striking Earth. It won't even be close enough to see without a telescope. It's likely the largest comet yet found in the solar system, taking millions of years to complete an orbit and currently heading towards the Sun, but with no chance of striking the Earth. And that's everything you need to know about the 100-mile megacomet that scientists have discovered. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.